Welcome to G Fun Facts Online. Few creatures on Earth embody resilience and longevity quite like the giant tortoise. These ancient mariners of the land have roamed our planet for millions of years, silent witnesses to its ever-changing story. Yet, in a tragic irony, these symbols of endurance have been pushed to the absolute brink of extinction by us. Decimated by centuries of overhunting and habitat loss, the world's giant tortoise populations have teetered on the precipice of oblivion. But this is not a story of loss. This is a story of hope, innovation, and unwavering dedication. It's the story of how a powerful tool, a technological cradle, is nurturing a new generation of giants and rewriting their fate. At the heart of this comeback is a technique called artificial incubation. But this isn't just about saving one animal. It's about restoring entire ecosystems. Giant tortoises are what we call keystone species. They are the gardeners and engineers of their island homes. Their constant grazing shapes the entire landscape, preventing any single plant from dominating and allowing for greater biodiversity. Their slow, powerful movements carve paths through dense vegetation that other, smaller animals can use. And crucially, they are masters of seed dispersal. By eating fruits and traveling long distances, they spread the seeds of native plants far and wide, helping to regenerate the very forests they live in. Their decline left a profound silence, a void in the delicate machinery of these island worlds. Today, we're exploring the in-depth story of how science is filling that silence, one precious hatchling at a time. To understand the monumental task of saving these giants, we have to look at the sheer weight of history. When Spanish explorers arrived in the Galapagos in the 16th century, they were so astounded by the abundance of these reptiles that they named the archipelago Galapago, the Spanish word for tortoise. An estimated 250,000 giants once roamed the volcanic slopes. The islands of the Indian Ocean were similarly a tortoise paradise, home to at least 18 different species. But this idyllic existence was shattered with the arrival of whalers, pirates, and settlers. For these seafarers, the tortoises were a tragic convenience, a living larder. They could be flipped on their backs and stored in the dark holds of ships for months, even up to a year, without food or water, providing a constant source of fresh meat on long voyages. The exploitation was relentless. Alongside this, their habitats were cleared for agriculture, and new, invasive species were introduced. Rats, pigs, and goats, brought by the ships, preyed on tortoise eggs and their vulnerable young. The populations went into a catastrophic freefall. By the 1970s, the Galapagos population had plummeted from 250,000 to just 15,000 individuals. In the Indian Ocean, the devastation was even more complete. By 1840, all but one species, the Aldabra giant tortoise, had been driven to extinction. The stories of individual species are grim. The Pinta Island tortoise was declared extinct in 2012 with the death of its last known survivor, the famous Lonesome George. The Floriana Island tortoise was thought to have met the same fate by 1850. And the Española Island tortoise was reduced to a population so small that extinction seemed inevitable. Just 15 individuals, 12 females and 3 males, clinging to existence by a thread. It was against this backdrop of loss that conservation efforts began, an effort that would pivot on one brilliant idea. The spark came from a frustrating reality. Even when conservationists could protect the remaining adults, their babies were not surviving. Invasive predators like black rats could decimate entire nests overnight. Flooding and landslides could wipe them out. For years, it seemed like a losing battle. But then, a groundbreaking study by scientists revealed a startling truth. They examined undeveloped tortoise eggs that were long assumed to be infertile. What they found changed everything. A majority of these eggs had actually been fertilized. The embryos had simply died at a very early stage due to environmental factors in the nest, like temperature fluctuations or dehydration. This was a game changer. The focus shifted from just guarding nests to actively managing the entire incubation process. The early days of artificial incubation were a testament to pure ingenuity. In the Galapagos, the first breeding centers in the 1960s used handmade solar incubators made of wood and lined with cement. Later, they created Rube Goldberg-like systems using electric hairdryers connected to timers, all in an effort to maintain a constant temperature. These methods were resourceful, but inconsistent and prone to failure. The real turning point arrived in 2017, with support from organizations like the Galapagos Conservancy. The breeding centers on Santa Cruz and Isabela Islands were equipped with state-of-the-art automated incubators. These high-tech systems use microcomputers to precisely control and regulate temperature and humidity down to a fraction of a degree. This technological leap has had a dramatic impact. Hatching success rates in these controlled environments have soared to an incredible 90%. Compare that to the wild, where success can be less than 10%. So let's step inside one of these giant tortoise hatcheries. The process begins with the careful collection of eggs. These can come from protected nesting sites within the breeding centers, or from nests in the wild that are deemed to be at high risk. The eggs, which are hard-shelled and about the size of a tennis ball, are surprisingly delicate. Each one is gently excavated and transported to the hatchery. There, it's placed in a container filled with a sterile substrate, like peat moss or a mix of soil and gravel. Then, it's placed inside the incubator. Now, the science takes over. The success of artificial incubation hinges on the precise control of two key parameters: temperature and humidity. For these hard-shelled eggs, a high humidity level of around 70 to 80% is crucial to prevent them from dehydrating. This is usually achieved by simply placing trays of water inside the incubator. But it is the temperature that holds the most fascinating and critical power. Like many reptiles, giant tortoises exhibit something called temperature-dependent sex determination, or TSD. This means the temperature at which the eggs are incubated determines the sex of the hatchlings. This discovery has been a revolutionary tool. For Galapagos giant tortoises, warmer temperatures of around 85 degrees Fahrenheit or 29.5 Celsius will produce mostly females. Cooler temperatures, around 78 Fahrenheit or 25.5 Celsius, will produce mostly males. The pivotal temperature, where you get an equal mix, is around 28.3 Celsius for the Espanola tortoise specifically. For the Aldabra giant tortoise, it's a bit different, but generally, temperatures above 29 Celsius tend to result in females. This ability is incredibly important for rapidly rebuilding a population. If you need numbers to grow quickly, you can aim for a higher proportion of females, who will eventually lay more eggs once they're mature and released. Throughout the incubation period, which can last anywhere from 90 to 164 days, the eggs are monitored daily. Keepers look for signs of fertility, a process called chalking, where the shell turns from translucent to a solid opaque white. They also watch for any signs of trouble. An egg that starts to dimple or dent could be dehydrated. One that discolors might mean the embryo has perished. After months of patient waiting, the moment of hatching arrives. The tiny tortoise, equipped with a small egg tooth on its snout, begins to pip or break through its shell. This process can take up to 48 hours, and conservationists generally let the hatchlings emerge on their own. Once free, they are not quite ready to go. They still have a yolk sac attached to their plastron, the bottom part of their shell. This sac provides vital nutrients for the first few days of life. So the brand new hatchlings are kept right there in the incubator on damp paper towels for up to 5 days, allowing them to fully absorb the yolk sac. But hatching is just the first hurdle. In the wild, the first few years of a tortoise's life are the most perilous. They are tiny, their shells are still relatively soft, and they are easy prey for native hawks, and especially invasive species like rats and cats. To give them the best possible chance, conservation programs implement a strategy known as head starting. This simply means raising the young tortoises in the protected environment of the breeding center for several years, typically 4 to 5 years for Galapagos tortoises. By the time they graduate, they are large enough and their shells are hard enough to fend off most predators. Life in the head-starting facility is a carefully managed routine. The young tortoises are housed in groups in enclosures, with controlled temperatures and lighting. Their diet is a carefully curated menu of native plants, supplemented with calcium to ensure proper shell development. For the newly hatched Aldabra giants in the Seychelles, their first meals are often chopped banana slices and leafy greens. The daily care is a labor of love, meticulous cleaning, fresh food and water, and constant health monitoring. Regular weigh-ins and measurements track their growth, ensuring they are strong and healthy for their eventual journey home. And that is the ultimate goal of all this work, returning these magnificent creatures to their rightful place in the wild. The reintroduction of captive-bred tortoises is a complex, carefully planned process. The releases are timed to coincide with the rainy season, when vegetation is abundant. The young tortoises are transported back to their islands of origin, a journey that often involves a boat ride, followed by a trek inland with park rangers carrying the precious cargo on their backs. To ensure the long-term success of the reintroduction, conservationists use technology. Many tortoises are fitted with small, lightweight GPS trackers attached to their shells. These devices transmit data on their movements, their adaptation to the wild, their migration patterns, and their role in the ecosystem, all without disturbing them. Camera traps are also used to monitor their health and behavior in their new homes. The impact of these intensive efforts has been nothing short of miraculous. Perhaps the most celebrated success story is that of the Española giant tortoise. From that desperate population of just 15 individuals in the 1960s, the captive breeding program has successfully restored a thriving, self-sustaining population of over 300 tortoises to the island. The original 15 founders, including the famously prolific male named Diego, who is credited with fathering at least 800 offspring, were returned to Española in 2020 to live out their days in their ancestral home. The first successful reproduction of these repatriated tortoises was documented way back in 1990, a clear sign that the ecosystem was healing and the population was on the road to recovery. Then there's the incredible story of the Floriana giant tortoise, which is a testament to the power of genetic science. Long thought to be extinct since the 1850s, recent genetic studies revealed that the ghost of the Floriana tortoise lived on. It turns out, 19th-century whalers had transported some Floriana tortoises to the nearby Isabella Island, where they then interbred with the native tortoise population. Scientists have now identified hybrid individuals with a high percentage of Floriana ancestry. Using this genetic information, they have initiated a selective breeding program to essentially resurrect the species. The first of these new Floriana tortoises are expected to be reintroduced to their home island in the coming years. It is a truly remarkable story of de-extinction in action. And it's not just the Galapagos. In the Seychelles, the recent success of the first ever artificial incubation of Aldabra giant tortoises has opened up new possibilities for bolstering their population and provided valuable insights that can help other threatened turtle and tortoise species around the world. Despite these incredible successes, the future of giant tortoises is by no means secure. Climate change poses a significant threat, with rising temperatures potentially skewing sex ratios towards all females and altered rainfall patterns impacting food availability. Human-wildlife conflict, especially where farms and tortoise habitats overlap, remains a challenge, and the illegal wildlife trade continues to be a threat from poachers. But the conservation community is not standing still. Researchers are actively studying the impacts of climate change and developing strategies like creating artificial shade and water holes. Efforts are underway to reduce human-tortoise conflict through education and promoting wildlife-friendly farming. The story of the giant tortoise is a powerful reminder of the destructive impact humans can have on the natural world, but it is also a story of hope, a testament to the power of science, dedication, and the unwavering belief that it is never too late to make a difference. These gentle giants, once symbols of a vanishing world, are now becoming symbols of a new era of conservation. The quiet pitter-patter of tiny giant tortoise feet, a sound that was on the verge of silence, is now echoing once more across the islands they call home, a melody of hope for a wilder, more resilient future.